Anyways, let's see if we can make this work. Okay, with that said, in terms of schedules, let's talk a little bit about schedules because I'm already like wasting time. My goodness. Hope Scarlett joins us because that's not cool. I continue to keep an eye out on my phone to see if she emails saying she. Okay, anyways, hope it works. Okay, if she pops in, let me know. Otherwise, it's recording. Okay, I thought that I would start today with a little bit of demonstrations again that has to do with physical properties because we were just finishing it off. First and foremost, we talked about mystery powders. We talked about science fair. As I mentioned last week, there's going to be a quick quiz on the subatomic particles, atomic theory, and particle theory of matter tomorrow. It's going to be super short. I will do a quick recap of it after this, just to bring everyone back to schedule. Wednesday is Take Your Kids to Work Day, which brings me to the question that John asked earlier. Who is going to work? Your parents work. Okay.
I might go to my sister's.
Who is going to work?
I don't know. I want to go to school.
No. I would love for you to come to class on Take Your Kids to Work Day, right? Yeah. It would be so fun. Anyways, seriously though, legitimately, who is for sure not going to be in school on Wednesday?
I don't know yet. I might shadow my sister for that.
Okay. Who for sure is going to be in school? Okay. Any chance you're going to be like miraculously sick by chance? I'm just wondering. Okay, I'm just saying. The reason being, for those of you who do come to school, it would mean that after you register ahead of time, a kind of program that a third party has created that is affiliated with PDSB. And I think it gives them a bunch of exercises and things that talk about different careers. And, I'm not exactly sure what they have planned, but the theme, what I was told is the theme of that sort of, student conference thing that we joined through Zoom is called You Belong Here. So I'm not sure if that is a theme based on them showcasing a whole bunch of different really interesting professions or careers and saying you belong here, or if it means, in general in school or staying here, and we just, use your academia to reach your aspirations. I don't know if that is what it may mean by you belong here.
I did not catch that. What is it?
It's a program, a kind of activity type thing that is created by a third party. We join in through Zoom and, they get us to, try a bunch of activities that are related to careers and work, right? I believe that's what it is. This is my first time experiencing it, and I was sort of told this information. So I want to register those. If you are coming, I need to register ahead of time. So I wanted to show of hands. But it seems like there might be a couple of people, so I will sign us up. If by chance you don't show up, then you don't show up. It's no skin off my back. I just wanted to know.
That's such a weird expression.
It's true.
It's a weird.
So that, well, yeah, it's true. It's like it doesn't harm me, I suppose is what it means. I don't know. Anyways, okay. And then Thursday, today after our lesson, I am going to give you a small activity that I think everyone should be able to do, and I'm going to make it worth a little bit of marks so that I can reward you. And that'll be due on Thursday. Friday is credit rescue. Oh, thank you. Credit rescue is I directly invite students who are missing stuff that have zeros or just fully based on just completely wow, completely forgetting something or whatever, it's an opportunity for you to come and make up those zeros. So you don't have those zeros. It's more applicable to grade 9s, 10s, and even 11s. For grade 12s, if they have zeros, I don't know. Anyways, that's a different topic completely.
Wait, is that quiz up there for this week or next week?
Pardon me? This is this week. Yeah. So for the record, if I want to summarize, today I still have to do a full thing, so stay tuned. And I want to give you an assignment that's due here. Small. Okay, it's like an activity. Tuesday, we do have our quiz. It's going to be very short, 1 page, double-sided, but there's like matching and stuff like that. That refers to these 3, and I'm going to do a bit of review today before you go, so you know exactly what's going on. Take your kids to work day. If you're not at school, you're not at school. If you do come, well, you're going to do something with me. Thursday, all that's left is another lesson. The small assignment thing that I give you is going to be due. And Friday is credit rescue day, so only select few people are supposed to come to school. Yes.
One thing is the store, is just gonna be like the third party.
It's going to be a third party thing if you are here. Yes, this class is going to be just that program. And if it ends early, then we just hang out. But that's about it.
Friday, you
Yes, sir.
only come to school if you like.
If you are invited by the teacher, then you come to school. Otherwise, you don't come to school. You will be marked absent, but that's not an issue because you're sort of told to stay home. Like it's not a, yes. That's how it's.
So for the teacher kids to work day, if you don't show up, you get marked absent.
Yes.
For this one?
But you can also just.
I thought that was for the credit risk.
No, yeah, for this one, I believe I do still mark you absent, but that's okay because when you get called home, parents will be like, yo, they're with me.
Okay, and also, take like, is it for both periods or just?
Take your kids to work days the entire day.
No, like for the workshop at school.
Yeah.
That's
Yeah.
good. I'm guessing it's the entire, I don't know.
Can I
Yeah, it's gonna be the entire day.
go to the bathroom?
Yes, yes.
What?
I think the one.
Oh. Okay, give me a second. Okay, I'm gonna have to send a direct link. Copy meeting. Sorry, I totally missed it. What was that, Maddie? You're done?
Oh, yeah, I
Yeah,
was wondering, can I go to the bathroom?
Yes, absolutely. Yes,
Is that credit risk day for every class?
yes.
So like,
Every,
still I'm not invited to stay home.
you stay home.
Alright. That's basically it. So no virtual class on Friday?
No. Let it be known. If you did not get an invitation from your teacher already, it means you have the luxury of staying home and chill.
Also, I was wondering what the BR assignment.
For Rutherford, I'm going to give you that today after today's lesson. Oh, man. Hope Scarlett joins us. This is terrible. All right. I thought I would start today by sort of recapping, giving you a little something fun to do, fun to see regarding physical and chemical changes after our mystery powders. And then we'll talk about these 3, what I expect you to know. Hi, Scarlett.
Hi,
Hi, Scarlett. Hi. Okay.
Oh, she can.
Yeah, of course she can. She loves us, right? Say yes. Say yes. Okay.
She loves me.
What
Yeah. Hi.
I'm gonna do, if this water works. No, this water is turned off completely. Dang. Okay. Yeah, I'll do the attendance again in just a second. All right, just to start this off, I spent so much time already. Would you please join me in the back as I try to demonstrate a little bit more on physical properties? That counter, please. The right, my right. Scarlett, how am I gonna get you to join in? Perfect. All right, Scarlett. Whatever. Okay, Scarlett, you're gonna have to mute one.
Hi.
Sorry.
Hey, girl.
No, it's because doing that.
Hi.
Oh, yeah, yeah.
Now we can. Thanks, Callum. Appreciate it. Okay. Sorry, I want to show a demonstration. Okay. All right, I'm gonna need everyone's attention now. Looking through, there are a couple of things.
Yeah, we became friends.
Maddie's best
Okay, we'll just that. All right. Okay. A couple of things. In the textbook, there is a section that talks about water's cohesion and adhesion in the textbook. In the same, I guess, subheading of physical and chemical properties. And I talked about the meniscus when we were doing the density lab, where we have to measure the water at the meniscus very carefully because water will stick to the side. So when you actually put water in here, it will create a bit of a lip. Right? Off on the side, it has a little bit of a dip. You have to measure it carefully. I want to talk a little bit more about that because when I was discussing it, it seemed like a lot of people were either unconvinced or they've never heard about it before. Know that, depending on what it is, right now, if I have two pieces of glass and I have to put it together, it's actually quite easy to pull apart. Make sense? I'm not doing anything magical. Right. In fact, it will come right off thanks to gravity. However, from a single drop of water, I'm going to try just a little drop. Okay, just a drop. Hold this. Thank you. Just a drop of water. If I were to place it, maybe a little bit more than a drop. Okay, something happens to it. In fact, it's not magical. Water is particles. Going back to the particle theory of matter, what do we know about particles?
They're attracted to the particle.
Right, so there's the explanation. If I told you this as part of my quiz, you would explain this phenomenon by saying particles attract each other. Glass made of particles, water, particles. And water is particularly special because of its, as you can see, adhesive properties, like glue. Glue isn't adhesive. Get what I'm saying? It's an English language, okay. But not all things will behave this way. For example, if I did the exact same thing, okay, if I did the exact same thing to, where's my other strip of plastic? You know, but like, oh man, anyone's got some scissors? Callum, scissors on my desk. Go.
Not allowed.
He's so helpful. Callum is a good person. There you go.
Yeah. Can Scarlett hear us?
Don't judge me.
Yeah.
Okay.
I'm not judging.
Okay.
I hear you. Yeah.
So mean.
I'm pretty
All right. Thanks. I'll remember that. All right. In the same way, if I were, this is not the heaviest, right? But if I were to place a large drop of water, there you go. Even so, it's actually not as, I mean, you do see the properties because it's heavy, but you'll see that not all things have the same form of adhesion. So in this case, these particular things, when it comes to plastic, yes, it's sort of, wish it was a bit heavier. If I were to have this right underneath, I'm not sure if it would be able to hold it. You won't believe me because you see that the bottom paper is clearly heavier than the top paper. But you're gonna have to, I'm gonna say right now, the adhesive properties of water depends on the material that it's trying to put together. My proof of that would be two graduated cylinders. When you place it together, it's a little hard to see, but Scarlett's gonna have the closest or the, I guess, front row seats. If you take a look at the meniscus of the glass cylinder versus the meniscus of the plastic cylinder, you will see that the plastic has virtually zero meniscus.
Wait, what's meniscus?
Meniscus is that little curved portion of the water. As I said, why is the water slightly curved? It's because the water will
to the sides.
stick to the sides. But as I told you here, it depends on the material. Plastic doesn't really stick with water. And so do you see the curvature?
Oh, I see a tiny bit.
Very, very little. So adhesiveness of water will depend on what material it is. But not only that, I have some more interesting stuff about water that I want to show you. This one is about cohesion. Cohesion is how well water will stick to itself. Now I'm cross my fingers. I'm hoping this will work. Don't blame me if it doesn't, okay? This is actually the first time I'm using this particular demonstration to show whether this is true or not. I hope it works. I failed too many demos with you already. Actually, let me. Okay. More water. Try to get to the top. Okay, so here you go. I am going to bring this aside, right? And if I were to just, take my hands off, you know what's going to happen, right? It's just going to pour out. But
Trying to compress water.
I'm going to try to do something and see if I can accomplish what you might call the impossible.
Oh yeah.
What?
Yeah.
Surface tension.
So what's happening? Water wants to pull through, but what's the only explanation? Instead of pulling through,
Yeah.
water, not sticking to the side, water wants to stick with each other. So instead of water actually coming out of the holes, they would rather, it's too difficult. It's rather holding together has more strength than gravity right now.
What happens if you hit it? Like the top will come out?
Good question.
Oh.
Bottom.
Hit it harder.
Hit it harder. It hit like the bottom
Hit it
part.
from the
bottom.
Hit it from the top.
not from the bottom.
So yeah, and then when I do that, of course, it sort of opens up. So there is some kind of invisible force. I mean, there's also a vacuum, but anyways, there's some kind of invisible force trying to hold these particles together. So there must be a way to explain that, especially if we're in the primitive ages and we don't know much about chemistry, right? So this is where this is where the thought started to go, and this is where the gears started turning. Not only that per se, I'm going to try this. It doesn't even have to be a mesh. I think this is small enough for this to happen. I'm going to do the exact same thing with the test tube with no mesh, but the hole here should be small enough that water wants to go down due to gravity, but the other water particles will pull it back up. So I'm hoping to see a bit of a wave. And you have to, all right, here we go. Here you go.
Oh my God.
Okay, I'm trying to keep my hand as still as possible, but do you see the wavering? The camera cannot. I'm gonna risk my computer by bringing this closer to the camera. It's okay.
Yeah, maybe.
But you take a look, my hand is relatively steady, but the bottom water, like as in this case, this reverse meniscus, I suppose, gravity wants to pull it down, but the rest of the water is trying to keep it up. Right? So the camera can't really see it, but it is a bit quivering.
Yeah, I can see that.
Right?
Yeah.
And so there it is. So water, it's not just some random thing you read in a textbook. They're actually trying to describe exactly what they see. Water has adhesive and cohesive properties. It's a physical property, not chemical. Yeah, exactly. But it's not changing material, it's changing in substance.
And they can't, and
It's
this
still water.
can't happen without each other. So if it was just cohesive or just adhesive, it wouldn't happen.
There you go.
So what
I'm glad it
exactly
worked.
is meniscus?
Pardon?
What exactly is meniscus?
A meniscus is just a name for the little lip that is created because water is sticking to the sides. Okay, let's go back. I also wanted to, I have to do a review. I'm glad it worked out. Okay, you're breaking the. Yes. Oh no. I'll speak to here because the mic is right here. Thank you, though. Listen.
Sorry, I'm getting you mixed up with another team.
It's
I
okay.
forgot your name. Is there an extra Chromebook in here?
Not with me, no.
Okay.
Sorry. All right. So let's start reviewing a little bit of this stuff, the subatomic particles, the atomic theory, particle theory of matter. It would be nice if I had props with me, but I threw all that stuff out. You're gonna have to deal with me using a chalkboard. Subatomic particles, we're gonna end up reviewing today anyway, so it's not a big deal. Let's talk a little bit about atomic theory, because you may not need to know what the scientist did, but I would like you to know what scientist or which scientist is affiliated with which part of the shape of the atom. Okay, starting off, we have that's a sphere, nothing special. The first person that came about was John Dalton. You don't have to remember the first name, just Dalton is fine. You do. In fact, does anyone have the sheet that I can use as reference? I'll just sort of like bring it up. I'll just put it in front and put it on the camera. 1 second. Stop video. Oh no, not video. Stop. I am going to remove pin. I'm going to start my video here. Yes, please. Thank you. Yes. No, I'm going to continue rolling. There's some people who requested today's lesson, so. It's okay. No, it's still picking up. That's okay. All right.
And it's like whoever last as the regular part.
Yeah, that's okay. Should I mute any? Okay, let's talk about this. The Dalton's model, okay? It's just a big sphere and atoms are particles. That's basically it. It says atoms can't be divided into smaller pieces. All atoms of the same element are identical and equal, or are different from other elements. That's basically it. Thomson is where you will have these spheres, sort of like chocolate chips on a cookie. So they're all negatives in a bed or a sea of positives. And essentially what he did, just because you're gifted, I'm going to say it very, very quickly. He basically had this tube. He was shooting atoms through it. And there he put magnets, essentially, in a nutshell. And you would expect that if they were just normal, the balls would just slip right through. But it didn't. It actually curved. It started to curve, which means something was being attracted to the positive or negative side of these magnets. And so he's like, there's got to be some kind of plus minus thing going on. Hence, this theory was born. Okay, just interesting stuff. Next comes Rutherford, and I told you about this example where it's like shooting a cannonball and it's bouncing off tissue paper, right? I gave that analogy the other day.
Wasn't it like a foil of gold?
Gold foil, that's exactly right. So the next one is, instead of in a bed of positives, the positive is like directly in the middle, and it's surrounded by these negatives everywhere. Right? It's not a bed of positives, it's actually a bed of negatives with the positive directly in the center. And that was Rutherford. Then comes Chadwick, and I was debating whether I should tell you about what he did. I thought I'd just summarize it for you. You don't need to know what the experiment is, but I just want you to be aware of it because I think it's interesting. Chadwick noticed that it's not just a positive, but there's actually neutral stuff inside the nucleus as well. How did he find out? Well, again, he was shooting these cannonballs, analogy, he was shooting these cannonballs into something, and he expected most things to bounce away because, again, these cannonballs were positive, and it sort of, if you have these attractions, they would actually bounce away. Some of these radiation things, right, some of these cannonballs actually punched right into it. So counter to Rutherford, think about it. If I have a positive and I come close to a positive, what's supposed to happen? It's supposed to perform. But this time, we were sending these heavy radiation pieces, and it was actually pushing off the positive itself. They were actually making contact. So there must be something here that's not positive because it's not bouncing back. Let's say it one more time. Here, positive with the positive and it bounced back. Something with the positive knocked it out. So this thing can't be a positive. There must be something else. And so they came up with the idea it must be neutrons. It's crazy. Back then, especially, when they had absolutely no real technology other than radiation. It's crazy. So that was Chadwick. You know, that's like the Coles notes of it. You'll get more into detail if you ever, there's all the minus. And lastly, it's the exact same thing, but the electrons are now in orbitals, and that is Bohr. And so today, when we get to today's little lesson, Bohr's model, which is basically a really smart student of Rutherford, this Bohr-Rutherford model is the modern shape of, or modern image of the atom that we are going to use, at least up until grade 10. Yes?
When was that Bohr method? When was that like found this? Like when did he?
The Bohr diagram? I believe it's like 1930s.
Has anyone made more tests since?
Oh yeah.
Yeah.
And so that's why up until grade 10, we keep the Bohr-Rutherford model. But as you get to grade 10, you realize, or you start to learn, you can handle more of these elements. The Bohr-Rutherford model, you will see, starts to fall apart once we get past about 20. Past. So they're like, what the hell, right? We have all of this. We have all of this stuff, but it's not working. So what do? Well, you got to dig deeper and figure it out because that's what science is. That's why up until the grade 9 level, when it comes to drawing these diagrams, I'm not going to ask you to draw anything beyond. I can ask you about protons, neutrons, and electrons, or like germanium or whatever. But when it comes to drawing, I'm not going to ask you for more than that. Continued review. Particle theory of matter. Do you remember the exercise we did together in class where I asked you to explain a phenomenon just like the water there? Right? On a quiz, I might ask you a question about something simple, like why does something that you see every day?
Water, when you spill water.
Oh, no, you don't have to. Well, even so our previous example, right? Like of how why do you have to let out air from your tire during the winter? Sorry, during the summer. Why do you have to put air in your tire during the winter? Questions like, why does a hot air balloon go up when you put, hot air in it? Just things that you can explain using the particle theory of matter. So please take a look at that worksheet and see if you can review. Subatomic particles, we're going to do this final review on it now to start our lesson. Woo! Which means I'm going to get you to do the review, and it's already time for us to go for a break. All right, let's do that. And then when we come back, I have a big something that we need to do as a class. We have to be on top of it, because if you don't, then you won't have all the instructions you need for your little mini assignment. So take this and see if you can fill in the top chart of the front page. Next back. 3, 4, 5. I'll do it in a second. Oh yeah. I was supposed to ask you to come up and pick one of these while you give me your mystery powders.
No.
Amazing. All right, sorry, I said I would do that. All right, everyone, now's the time. If you have your mystery powders ready, please come on up, put it down here, and pick one of these as well. Get it to me before I hand it back, and I won't. Just leave it here.
Well, I did mine on my.
Thank you,
I did the questions on my computer.
Oh yeah, you sent me an email, right? Yeah, that's fine. No, thank you. Yes. Nope.
I mean, like,
You can. That's all I really need, as long as your name is there. Alex. Nope. That's for tomorrow.
I took her, and it's only these pages. I didn't add.
That's okay. That's all I need. Thank you. Sterling and Uma, I'll try to get these back to you as soon as possible, the science fair, okay? So you can get
Oh,
started.
did you have to take yours?
If you have a copy of this already, you can get started. I'm sure it's good.
Sorry.
Stop this.